My name is Anil Gupta. I'm the co-founder and CTO at Wyebot. I've also been in the networking industry for over 25 years and started Wyebot about 7 years ago. I'll actually start off with the system architecture for our solution. So our solution essentially consists of three components. Actually, there is the Wi-Fi sensor, which actually I'll hold this sensor up to you, and I'll also pass it around for those who have never seen the Wyebot sensor. So that is the multi-radio sensor. It pretty much looks like an access point. It's largely built on a platform like an access point. It has three Wi-Fi radios in it. Two of them are 11 AC 4x4 Wave 2 radios. The third radio is the one that is kind of, I wouldn't say swappable, but like it is the one that, which different models we have. There is the 11 AC model, there is the AX model, and now we will be coming up with a 6 gigahertz model of that as well. I can pass this around, but before I do that, so it has one PoE Ethernet port, and there is DC power supply possibility as well. Somebody had asked the question, can this sensor be connected, to the internet via a different mechanism other than the PoE? So there are three mechanisms. You can certainly do the PoE Ethernet, or you could do Wi-Fi backhaul. And the third question was, can we do cellular as well? So we do actually have a USB port on the sensor by which it can connect to the via a cellular network. That has been tested in the lab, but it has not been productized as yet. We could consider that certainly in the future, but yes, it's a possibility. So I'll pass this around for, if you want to kind of touch and feel the sensor, if you've never looked at that. So as you can see, the solution, there is the Wi-Fi sensor, which has the three radios. The big and very important thing with our solution, it was really born with simplicity in mind. And I really want to emphasize that a lot, because having worked in networking Wi-Fi for multiple decades, simplicity for us was not like an afterthought. So the one difference that you will see with our solution is when we say plug and play, we actually mean 100% plug and play. There is actually no serial port on the sensor for you to plug it in, let me configure any of that. You plug the sensor in, and that's it. As long as the port has internet access, it can get by default, if it can get an IP address and can communicate to the internet, you are done. So this becomes extremely important when you are looking at remote locations, distributed enterprises, where you cannot either go yourself or send an engineer. You simply ship out the sensor, plug it in, and within 5 minutes, it will start collecting data that you can start working on. And I know, having been there myself, you go out there with your bag of tools, with your spectrum analyzer, with your Wireshark, packet analysis, and you collect all the data. And how many times has it happened to all of us that you go there and the event does not happen when you are there, and when you step out or you went to the restroom and now the event just happened, right? So I've been there myself, and I know how painful that has been. So, and that is the whole point with our solution, that it is capturing data 24/7. So when we kind of formed the company as well, we said, oh, should we do a software-only thing? And the answer is, like in real life, all of you go with your bag of tools. So the answer is no, and I know you asked earlier, why is there a place for an overlay solution, right? So the reality is, if you don't have a third-party independent, I almost call it as like a microphone in a room architecture, which is somebody else actually listening to all the conversation that is going on, you really don't get the view of the device. So that is the reason, out of the three radios in this sensor, two of them are completely passive. As a matter of fact, they will, like even the FCC certification, we never, like they are they will not transmit. They are completely passive. And the third radio in the sensor is a multi-personality radio. And by multi-personality, I mean it can do the background scanning. It will do the channel hopping and all of that. It can be used for Wi-Fi connectivity or backhaul, as I said, to the internet. And then lastly, it can be used to do network testing, synthetic network testing as well. So the two radios, what they do is they will, by default, they are configured. One is configured for 2.4 gigahertz band. The other is configured for 5 gigahertz band. You can certainly change them to be both 2.4 or both 2.5, whatever way you want to. The default logic by which they will select a channel is that they will look for the strongest beacon close to them, and they will pick that or assume that as the channel. We do have a feature whereby you can say that XYZ, like for example, today, mobility or whatever, mobility field day is the SSID. So you can tell the system that my SSID is mobility field day, and then it will make sure when it does the scan, it picks out all mobility field day SSIDs, and then will pick the strongest beacon from that to configure itself as the automatic channel. So if you have an AP that is on 2.4 and 5, one radio will automatically tune to the 2.4 of the AP, and the other one will automatically tune itself to the 5 gigahertz of the same access point as well.
So does that mean that with some of the newer features coming in, AX that is going to receive channel change notifications and in real time follow?
It does follow, yes, absolutely. Even without the channel change notifications, because vendors have done it. And we've been a vendor in the past life myself as well, having worked for HP Aruba. But whether that happens or not, we are tracking. So as soon as the channel is lost, we will immediately, within seconds, we will figure out that my primary channel has been lost, and we will actually follow the AP. So as the AP changes channels, the sensor will also change channels. Now, since you asked that question, there has also been recently a request, and I'll show you that in the demo piece as well. There were some people who said, or some of our customers, who said, I want to make the sensor track a specific BSSID. So not just the SSID, I have deployed it right next to this AP. And I want to make sure that the sensor tracks this particular AP only, because what can happen with the SSID tracking is that if the nearest AP takes longer to select a channel, then we could now be tracking an AP which is farther away. So the BSSID tracking mechanism, which is a feature which we'll be introducing in our next release, will allow you to specify the BSSID, and we'll just keep waiting until that one shows up. And you only need one, by the way, because we have all this logic, and I'll show that in the demo piece, whereby we can figure out, kind of reverse engineer the whole back end of what are the radios, what are the APs, belonging to a given access point, which is a very cool feature, of our system.
I can really see the value of getting a client perspective, right? But I know you said that you're 11AC.
Mhm.
I'm struggling with how this would work in an 11AX environment, where you have now your channel, different parts being used by different users with OFDMA.
Yep.
And also with beamforming, with the multi-user MIMO, where users are, the RF, if you like, is being captured in different places. It's going to have a different experience. So I'm struggling, although I really like the concept and see the necessity for it, I'm struggling with how would this work in an AX environment. Can you give me some insights there?
Yeah, absolutely, absolutely. So as far as the AX, the OFDMA concept, that the kind of call it, the challenge remains the same for anybody on the outside, right? If you are a third party kind of independent entity sitting on the outside, if you're looking at the smaller RUs or the let's just say 2 megahertz, 4 megahertz, 8 megahertz channels, then you can set the sensor to right now, for example, like a 20 megahertz channel width, etc. And what we do kind of to not circumvent, but closely mimic what best is possible as an independent third party, seeing that from the outside, is our general recommendation is that if you can mount the sensor generally within 3 to 6 feet of the access point, then it'll largely see the same things as the client, the whole beamforming when the client is doing or the AP is doing, either directions, it'll have the same signal strength view of and the beamforming view of the client. Now, there have been cases where we had a customer who was saying, oh, I'm actually troubleshooting a smart board, for example, right? And now you could actually place the sensor next to the smart board. So you want to see that client device's view of the AP rather than the AP's view of the client. Certainly, when the sensor is mounted closer to the AP, it will be able to capture more data frames, as opposed to when it is mounted or sitting close to a client device. Does that answer somewhat?
It does. You're saying I have to deploy my sensors closer to the access point in order to get, the RF coverage. But how does that deal with the specific clients? So if I have, let's say, 4 clients using a 20 megahertz channel,
Yeah.
How do I distinguish what a client's problems are when you don't know which part of the spectrum that client is actually been allocated? See what I'm saying?
Talk to the client software, does that make sense?
Yeah. So to that extent, we understand what you're talking about, and this is where there is another part of the story, if you will, which is there is the headless devices, etc., which need the independent outside view from a sensor perspective, and then there is the other scenario which you're talking about, that what can I see instead of the synthetic behavior? Can I see the real behavior? So our objective is we are working on a client-side application software as well, which will give you that view, right? So then you can see from the client's realize, if you will, what is the client's user experience. So that'll be different than the sensor view. But we feel that there is space or there is place for of course, the overlay solution, because you want that independent view, and B, there are going to be headless devices like the Rokus and the Chromecasts, where you cannot, install client software. So there is the sensor that comes in handy, and then there is the laptops, the MacBooks, the iOS, Android devices, etc., where you can get the device-centric, realistic view as opposed to the outside view from a sensor. Right, so it's complementary.
So just to clarify, just and extend upon her question. So you're saying like currently with an AX, if clients are using different RUs, it will not, like the AX sensor is not able to kind of determine like which clients are using different RUs and.
So right now the third radio in the sensor, essentially it can act as the AX Wi-Fi client.
Okay.
But if you talk about right now, the other 2 passive radios, those are AC radios. So, but the client perspective or the synthetic network testing can certainly do.
Okay.
You can also do packet captures as well, and that's another thing I'll talk about, in the demo, with our sensor as well. But you'll have to then set the frequency and the channel width appropriately, or if it is using the auto channel mechanism, following that. So at the moment, the 2 passive radios, they will automatically select the channel width as well as the channel based upon the strongest beacon. So it'll look, if your AP is configured for channel 36, 40 megahertz, it'll automatically tune itself to channel 36, 40 megahertz, etc.
So to be explicit about it, you don't have an AX feature set specifically developed just yet. Is that correct?
No, so the issue is AX. The issue is the only way you're going to see multiple RUs in use is going to be with a packet capture. If you're not doing a packet capture, you're not going to be able to see who's doing multiple RUs because you're just seeing layer 3 and above. You're not seeing the layer 2 data. So you're going to have to be doing a packet capture. So my understanding, because I've been going through your documentation,
Yep.
some of your videos here, it looks like PCAPs have to be initiated manually. There's not like a buffer PCAP that's going on all the time, right? Where that you can
No,
go back. and
no,
look
that's
at.
not true. That is not
So
true.
you can't do like a buffered as well.
Yes.
Okay.
Yes.
So that would be one way where you
Yeah.
could potentially, if you're on the right channel, is possibly capture that PCAP and see those multiple RUs and the clients that are.
Yes.
But you're not
Plus
going to
with-
be able to see that on the passive radios. Even though they're in passive mode, they're not doing layer 2 passive. They're doing layer 3 because you're looking at because your stuff I've been seeing, and maybe I'm wrong, is all like DNS and DHCP.
No. We do. So let me quickly, transition over to the demo section, but finish this slide and then we'll go to the demo
So I
piece.
do have a question that does pertain
Yes.
to this slide, though. So on the website, you list the platforms that you're compatible with. It's a very long list, very impressive list. Does that compatibility? So you're talking about like, well, we'll try to lock onto what channel the AP is on. Are you doing some sort of integration with the platforms where you're like, through some mechanism, depending on what the platform will allow, getting a list of APs? Are you extracting information from the wireless infrastructure, or is this all just passive?
All passive.
So then what's the point of the list of platforms you're compatible with if in theory you would be compatible with literally any Wi-Fi infrastructure?
So there's a couple things which I would say benefit from that or like apply to that or that logic applies is so yes, of course, we try to be completely passive and not fetch data from a wireless LAN controller through an SNMP system or anything like that, because we said we really want the view as an independent client would get a view, right? So it is completely passive. Now, where does it, the integration or the vendor specific stuff, if any, comes along? So as an example, we all know beacons, for example, can advertise the name of the access points, right? So just like, other vendors, we actually go to extreme lengths to figure out the name of the AP, automatically, and, more secret sauce than most other vendors that you'll see, that we can figure out the names and So the goal, again, goes back to what I had said earlier, really, simplicity in mind, and that we don't want the user to have to plug in all of those, A, those credentials, and B, if we can figure that out all automatically, that's even better. And that's what our objective there is. Do you have a question?
Yeah. Yes. One was about. Did I hear you say like there's an application you're working on that will actually go on the client and
Yes.
report data back?
Yes.
Okay. And
Yes.
it'll just report back in the cloud and
Yep.
all that.
Yes.
Second question was, I know this is like an access point, kind of like a form factor, right? Something similar. So you mentioned this clever touch screens, for example, or like a client view, I guess, if we're talking about. Is there something on the roadmap with a smaller version of it that I can, install it on the wall or
A temporary
even a temporary thing or?
So yes, we've still continue to have discussions around that and welcome feedback from this community as well. There are like pros and cons of having the smaller version, right? There are many people who've said, okay, let's just have a single puck in the wall, single radio kind of a thing. And we could explore that. I'm not saying it's out of question, but there are times when you actually want the dedicated non-time sliced view of the channel. And I think that's where this platform brings, because you do get those passive radios which are completely listening non-time sliced and you don't miss any event. The challenge with the time sliced scenario is because if you go with a single radio puck kind of a thing, tinier, or you can call it like a micro sensor, then it's what are the drivers for that? Primarily, I would say cost reduction of the sensor, right? That's why you and by the way, we don't sell this sensor, so this whole thing is a subscription thing, but that's different altogether. Did that answer your question or?
Yeah, it's fine. Yeah.
Yeah. So on this slide, sorry, go.
Just a quick question. Sorry.
Yep.
I noticed on the slide it says it's got a Bluetooth radio in the sensor. What's that being used for?
So we haven't exposed a ton of data on the Bluetooth side. We have done experiments, like we can figure out what are the Bluetooth, devices in and around. But like most people have wanted more of the spectrum analysis piece. So the two radios, which are passive radios on the sensor, they do have spectrum analysis capability. So what we do with that is that we actually, instead of showing you all of those, waterfall, charts and graphs, which I know many of us techies would like, but like we know for the kind of end user, at the end of the day, you're trying to figure out what actually happened, right? So we, instead of showing you those waterfall charts, we actually tell you what was the event that happened, how long did it last, what channels did it affect, what was the percentage of, channel impact on all of those, of all that non-Wi-Fi interference that happened. So there is spectrum analysis built in. The Bluetooth data today is not exposed, the Bluetooth data in terms of, okay, what are the Bluetooth devices around that? But if there is interference caused by Bluetooth, that is reported by our system.
Okay, and is it sort of traditional Bluetooth, or does it look at BLE devices as well?
Yeah, so as we upgrade, we'll get newer Bluetooth BLE capabilities as well, but at the moment it's traditional Bluetooth devices.
I just want to be clear, everybody in this room is Wi-Fi is our thing,
Yep.
right?
Yep.
And so for us, definitely it matters to look at higher layer stuff, but for us,
Yep.
it's really the protocol layer that we care about, and
Yep.
also the layer 1 as well.
Yeah.
And I'm not saying that the other things don't matter, but I think a lot, and I guess if you might sense resistance or kind of questioning, it's
No.
because we've had sensors for years.
Oh yeah.
And I personally, I've never found a use case for a sensor. Aruba makes sensor. I mean, you guys make, all kinds of people
Yep.
make sensors. And I can't find a use case, a real true use case where it actually makes sense. Because if somebody's having a problem with DNS, it's not a Wi-Fi issue, and you're going to see that somewhere. You're going to find that the DNS is slow or having a problem, on your desktop, on your laptop, whether it's plugged in, whether it's on Wi-Fi.
Yep.
Right? If DNS is slow on Wi-Fi, but it's not on wired, then I guess maybe that's something. I mean, that could point to something, but probably not. I mean, it's just. I mean, what does that really tell you? Does that, your channel's in use? You have a lot of devices using the channel. One person doing a BitTorrent. There's a lot of reasons why that can happen, right?
Yeah.
So how? I guess the difficulty we're having is you're saying, okay, you put one sensor, it gets onto the strongest channel. Well, there's other channels around there. So yeah, you're focused on that channel and you have that extra radio that's looking at other channels,
Yeah.
right? But for us as wireless engineers, the reason we do surveys and things like that is because we're trying to get a holistic view of everything, right? It isn't really, one channel to us doesn't really help us, right? And so understanding whether DHCP DNS is doing a thing or not on the wireless has some value. I'm not saying it's valueless.
Mm-hmm.
I'm just saying it may not be the most critical thing, at least for us as wireless engineers. And so that's why I think you're getting a lot of questions about, like, are we going to see RUs? Are we going to see this? Because we know by experience that, yeah, this stuff's important. But I mean, if you have these issues, you're going to see it on the wired side too. So you're going to find those issues. The issues we care about is what's actually impacting my wireless, right? And it can be a problem, or it could just be just the way the Wi-Fi is working. A lot of utilization. If you're going slow, it doesn't mean the Wi-Fi is bad. It just means you have a lot of utilization and the Wi-Fi is doing exactly what it's designed to do.
I 100% agree with what you said.
I'm going to disagree.
Yeah.
I'm going to disagree with him a little bit.
Okay.
Because working in an enterprise environment, I spend maybe more time than I should proving it's not the wireless. And
I was going there.
and so just being able to go, no, dude, it's an issue. It's not an issue.
No, that never happened.
That can be somewhat helpful because I do have some environments I support that are wireless only. I was just doing a bring up in a data center the other day, right? In the text, you only have wireless, oddly enough, in a giant wired data center to plug in. And it's like, no, we're having a problem. And I'm like, well, no, the problem is your DHCP scope isn't configured, and here's the packet capture that shows you that it's not configured. So there is some useful for this in the enterprise environment. Mm-hmm. The other stuff is also very important because those are fun problems to solve. I just wish that I got to spend more time solving those than telling the DHCP guys they need to get their scope configured.
That's fair.
So I was going to answer that way. So to piggyback on that. So as Wi-Fi engineers, I know we have a ton of fun solving those, right? But the real challenge why Wyebot was born, that whole model is very manual. It does not scale, right? Yes, you have fun, solving those, going in, taking packet captures, but imagine if you have to do that for 300 locations, for a given enterprise, across the country. Are you going to fly down to every site and then prove it? So it's the reduction in and we call it mean time to innocence, what he just said, that you're always trying to prove it's not the Wi-Fi, right? So, and when you say, oh, what is it going to do monitoring one channel? But if you can prove remotely without going there, just ship out one sensor over there, plug it into the network. If there was a DHCP problem or a DNS problem, and you have now a known good device that if it connects, this is how it's going to behave. It's not somebody's laptop or any handheld device. So there are use cases where you are either doing reduction in the mean time to resolution. That is the goal. You can absolutely find it. I used to have fun too. I would go out there, go on site, spend a couple days over there, but the model doesn't scale. That's where you say there is a use case for sensors, where you can do all of this remotely. We now many times go out, just ship out, like when Roger said earlier that we ship out sensors. We simply ship out the sensor, they plug it into their network, and remotely sitting at my desk, I can get a very good idea of how their entire network looks like. And when you say, you earlier said that I can prove the Wi-Fi is not working, right? But if you are the IT person, right, it's almost like the buck doesn't stop there. If the exec asks you, all right, I don't care. Okay, you prove to me the Wi-Fi is not the problem, but fix the damn problem. Like, where is it, right? So we come in, our view is that you have to get a full 360 view. Look at the wired, look at the wireless, look at the configuration, look at the RF interference. If you need to do a packet capture, do that. And that's all built into the sensor solution. So that's where really the power comes in. The manual method absolutely works, if you can, but for many enterprises, that doesn't scale. Does that help answer to some extent?
For me, no.
No, okay.
I still don't find use cases for. I ask everyone. I'm like, give me a real use case. I've read through your white papers, and I'm like, I still don't see the use case, and that's me. Now, the reason I'm doing this is because I want to know. If this is something that can actually help me and my customers, I want to know how, so that I can implement it for my customers. But for me, what I want straight answers. Like, what is it actually doing that I can actually use this and actually provide some assistance? I think Ali's point of being able to have a mobile unit that we can take and say, hey, they're having a problem in QA. Can you put a sensor over in QA and plug it in? And then I'll see it come up on my dashboard, and we can do some analysis now in QA. That, to me, has more value than having something that's statically on the ceiling and doesn't move. And I'm like, let's see how it acts in that. So
there are two use cases, So yes, there is a use case where some people will deploy some statically fixed, and there is many of them will have a few floater units, right? Which you can, I know that area is critical. People complain about over there a lot. I can either have one sitting there permanently or a couple sitting there permanently. And then I have a few floater units, which when there is a problem, I'll ship it out, just ask somebody to plug it in, and then I can get a view of what is going on in the environment. So yes, that is certainly, a use case that a lot of people do it that way as well.